Hi, welcome to MooMooMath. Today we are going to talk about sketching vectors and solving basic operations with vectors algebraically. So what are the basic operations we're looking at? We're looking at scalar multiplication, addition, and subtraction, and a combination of those. So we'll first look at it graphing on a Cartesian coordinate plane and then algebraically. So here we go. We've got two vectors, a sub 1 and a sub 2. So the first little sketch we're going to do is 2 times a sub 1. So this is a scalar multiplication. We're finding or sketching what 2 times the first vector is. So what I'm going to do is I've actually got these cloned so I can drag these over here. So there's an a sub 1. But I want to double that, so I'm going to put 2 together. So there we go. There's the sketch right there for a sub 2. Okay, or 2 times a sub 1. Now let's look at the opposite, or negative 1 times a sub 1. So we're going to take a sub 1, this vector, and we're going to sketch it. But we're going to take that vector and we've got to negate it. So it's going to go in the opposite direction. So anytime you've got multiplying by a negative, it's negating both values. So instead of positive, positive, we're going negative, negative. So if you had a positive, negative, it would be a negative, positive. Just negates the order. So there are the first two. Now let's look at a sub 1 plus a sub 2. We're going to use that tail to head or head to tail method. So let me go back, and we know this is a sub 1. Now let's add to it an a sub 2. So I'm going to take this one and put those together, and boom, we have got the sum of two vectors. But really we're not done, because what the answer is the resultant of putting those together. So that one that I sketched, the dashed line, or the dashed vector, that's actually the solution. That's called the resultant vector. Okay, so now let's try half of a sub 2, or vector a2, a sub 2. So I'm going to go ahead and put a sub 2, there's my vector, but I want it to be half the length. So I'm going to shorten it to half its distance. So that would be a sketch. Not with this one in there, so let me take that one out. So there is the sketch for number 4, half a sub 2, the vector. Okay, now let's try negative 2. So we have a scalar of 2, but then we're also going negative. So twice as long in the opposite direction of a sub 2. So let's do that. Let's take a sub 2. Here's an a sub 2. So there's our vector. But we want it to go the opposite direction. So it's going to go this way. And then we need to double that. So let's take that and copy it. And I'm going to paste it. Whoa, I pasted the wrong thing. Let's try to copy what we need. Copy. Paste. Boom, there it is. And we're going to lay it right there. So because I can't draw really a resultant, I guess I could draw a resulting vector on top of it, but that is the final answer, because it would be that length. That's a resulting vector of negative 2 a sub 2. Now let's try one that's got 2 a sub 1s minus half, or 0.5 a sub 2. So what is that going to look like? Whoops. Let me grab these and get them out of the way so we can sketch this last one here. These out of the way. Okay, so I need 2 times a sub 1. So here's a sub 1, and I want 2 of those, or double the distance. So 2 of those, and I'm going to subtract from it an a sub 2, but it's negated. So here's my a sub 2, okay, and I need to make it smaller, half the length. And I also want it to go in the opposite direction. And I'm going to use the head to tail method and put it here on the end. And there we go. that would be the diagram or the sketch for that vector, but I also need to go back and draw my resultant vector from beginning to end, and there is my resulting vector. Okay, so that's how you sketch them. Now, let's do it with a Cartesian coordinate plane. So let's draw each of these vectors. So the first one I'm going to draw is V, and I'm going to add 2 of U's. Well, I have coordinates, so I can actually, write these out a little bit easier, or draw them a little bit easier. So I'm going to start with V, which is -1, 4. So there's the first one. And then I'm going to add to it 2 U's. So U is 4, 2. So from here, I'm going to go over 4, up 2. So there's one of the 2 U's. And then over 1, 2, 3, 4, up 2. And there's the second one. So there's my sketch, but what is my resultant vector that I need to draw? I'm going to start beginning to end, and there's the resultant vector. Okay, so what is that vector? Let's see if we can figure it out. That one's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the vector that results is the vector 7, 9. Now let's do that algebraically. So I'm going to take the first vector, and it's in standard position, so it's a 1, 4, and I'm going to add to it 2 times the vector 4, 2. So algebraically, I first have to multiply by my scalar. So 2 times the 4, 2 is going to be 8, 4. So that's the result of putting these 2 vectors together. Then I'm going to add to it the original vector, which is V, which is -1, 4. So let's add the horizontal direction, and that gives me 7, 8 plus -1. And then 4 plus 4, that's 8. And there we go. Whoops, did I count this wrong? I started at 1, 2, 3, 4. Oh, I started this one at 5. Well, I originally blew that one. It should have been here, and then these 2 should just drop down. Let's see if I can get it to work correctly. Well, that was my bad. It should have looked like this, and this should be 7, 8 instead of 7, 9. There we go. But you can see I checked it algebraically, and I had actually missed it graphically. So it was a good way to check it. So there we go. And that's how you can do it algebraically. So you have the visual on the graph, and then you have algebraic. So that's where we're going to stop. A quick little lesson on sketching vectors and then solving them or finding that resultant vector algebraically. Hope this video was helpful.